Okay, well, hello everybody, and welcome to another presentation of the online ColdFusion Meetup. I'm Charlie Earhart, and I'll be your host for the next hour or so. And in this edition of the Meetup, our 265th, being held on Thursday, August 6th, 2020 at noon U.S. Eastern, we've got Klaas, who's going to be presenting on I Didn't Know S3 Could Do That. And before we turn it over to Brian like we normally would, I want to just take a couple moments and talk about a couple things, since this is new and different that we're running on Zoom. So you all know that. And for those watching the recording, it maybe wouldn't have been obvious to them. So we've decided for various reasons to switch, out from Connect. There's a new version coming, but we'll see if that necessarily would work out for us. But I want to ask you first to forgive any bumps in the road as we get started. There's some things that are different enough. And I use Zoom every day for one-on-one sessions, the consulting that I do, but using it in a group environment like this, and it's just different. So I'm getting used to some new parts of it. So again, please be patient with us. And I want to point out that you need to open the chat and the participants pods if you want to watch those things or see, whatever, you have to open it. Whereas with Connect, we could pre-configure it to open those automatically. And I just want to remind you, all the sessions are recorded and they're offered at recordings.coldfusionmeetup.com. And all the sessions since 2015 are also up on YouTube and will be going forward. So again, those links are all at that recordings.coldfusionmeetup.com. And finally, I just want to point out, I will be announcing some more sessions later today. All right. And with that, let's go ahead and turn it over to Brian. Thank you, sir, very much for coming on. I'll stop sharing.
Thank you for having me.
You betcha, man.
All right. Just need you to promote me back over to the host role.
Right. Yes. So there's an example.
Okay. I'll start my video because I'm one of those weirdos who likes to be on camera. I do lots and lots of Zoom sessions for education and training. And so I know some people like having the host on camera, so I don't mind doing that. I have a whole setup for it. So here we are. Hopefully you can all see my slides now, and let's get started. So I like doing things that let me be a developer, that make my life easier. I don't like worrying about servers. I don't like worrying about storage. I don't like worrying about networks. There's a bunch of stuff that I'm not, I'd much rather not do. And I want to focus on building code, and I want my team, I manage a group of people, and I want them to be able to focus on building features and code and making visible progress to our clients and to our customers. Those are the things I want to do. And so for me, one of the things that lets me do that is to use pre-built cloud services like the stuff in Amazon Web Services. And if you've ever seen me, I spent probably the last, 7 years talking about various usage of Amazon Web Services. And I'm not a shill for Amazon. I swear I have lots of problems with them, and they can be very expensive at times. But there are some services that are just amazing that I can't imagine working without. And if I go back in time, I would be like, I would have used this from the beginning. And one of those is Simple Storage Service, S3. As it's more commonly referred to. And S3 is awesome. S3 is great, and it's pervasive on the internet. Some people call it the file system for the internet there, because it is so heavily used. It powers the web in many cases. It's not just big recent startups like Airbnb or Netflix or Pinterest or even Reddit. It's really big scientific data companies like NASA and Pfizer, who store terabytes upon terabytes of data inside of S3. There's over right now, I think it's about over 420,000 companies around the globe use S3. That's a huge number of companies, big and small, who use this tool. And it's great because, it allows you to store stuff cheaply and do more than just storage, which is what I'm going to talk about today. But the primary reason why people use it, right, is because it's super easy, cheap storage. And what's really kind of incredible about S3 is that it is so big and so pervasive that in a single AWS region, a region is a geographic data center for AWS around the world. And right now there's, I think, 25 of them, with 2 more coming online supposedly this year. In a single region, S3 manages 60 terabits of data per second. That's in a single region. 60 terabits of data are flowing in and out of S3 per second on an average day. On a really busy day, it goes up to a lot more than that. But think about it, 60 terabits of data flowing in and out of S3, which is pretty remarkable when you think about it. And as CFML developers, as ColdFusion developers, we're really lucky because integration with S3 is already built in to our CFML runtimes, both Adobe ColdFusion and Lucy, and has been for years. We can just say, instead of pointing to a file on our local file path, we can say s3://. And that tells ColdFusion or our CFML runtime, hey, this is going to be an S3. And CF just takes care of the hard stuff, right? Takes care of the magic stuff and just does it in the background. And you can write files, and you can do in tags and script and read files and do pretty much any file-related integration you need to do directly from ColdFusion and our CFML runtimes. And that's awesome, right? That's super easy, uploading, downloading files. But there's so much more to S3, so much more than just uploading and downloading files and file storage. There's lots of different features. I'm going to try to go over as many of them in the time that I have here today to do that. And the way I'm going to do this is I'm going to use the AWS Java SDK. This is really how you tap into the power of AWS from within your CFML runtimes. What's great about it is that basically you just download the jar file from AWS, the AWS Java SDK jar file, the 1.x version, not the 2.x version. Although that may change in the future, but the 1.x version, and you just drop that whole jar file into your CFusion lib directory or your Lucy server context lib directory, and you're good to go. And you can tap into any of the services that AWS provides. Because what the CFML runtimes provide is nice, but it doesn't do even a fraction of what you can do inside of AWS or even in S3 itself. And pretty much everything I'm going to show you today is actually going to be natively supported in ColdFusion 2020. So you won't even have to add in the AWS Java SDK jar file. In ColdFusion 2020, there's going to be native support for S3 and Azure Blob services for doing all this kind of work. They're each a little bit different, and the stuff I'm going to talk about today won't apply necessarily to Azure Blob services, but it will certainly apply to everything. Everything I'm going to show you today will be supported natively. That means you don't have to add the AWS Java SDK in ColdFusion 2020, which is pretty cool. And then you won't be writing all this Java and create object or making all these objects. You will just be able to do it natively within within ColdFusion 2020. If you want to learn more about that, there's some recordings about it. I think Rakshith is doing or just did. He's the manager for the Adobe team. He just did or is doing in the next few days a whole walkthrough of the stuff that's coming in ColdFusion 2020. So there's really 4 things I want to talk about today. And if you have questions as we go along, please feel free to type them into the text chat. I'll gladly answer those questions for you. But there's 4 things I want to talk about: security, money, very important, power, and everything else that sort of follows into S3. So I'm going to be spending most of my time really on security, money, and these kind of powerful tools that are built into S3. And then we'll get a little bit into the literally 30 other things S3 can do that I'm not going to be able to show you in today's session a little bit at the end. So let's start off. Before I start off with that, I do need to cover one thing in code first. And I'll make the slides this available to you after the session. They're already actually up on my my blog, brianklaas.net. And the thing I need to show you first is how to upload a file using the AWS Java SDK. Because everything I'm going to show you, you have to use the AWS Java SDK. And you're really ultimately going to have to also upload your files via the AWS Java SDK in order to tap into the real power and the tools that S3 has above and beyond just storing files and grabbing files out of there. So I need to first show you how to upload a file via the AWS Java SDK, because that's the basis really for everything else I'm going to show you. And the code that I have is all in my AWS Playbox app. You can see the link on the screen here, the URL on the screen here at github.com. I will show this URL again like 2 or 3 more times in the session and at the end. So if you don't grab it right now, you can certainly grab it a little bit later. But it has demos for accessing not just S3, but a whole bunch of other AWS services from within your ColdFusion applications in this app. It has code that works, and you can use it and build off it, and lots of people have, and I'm glad I can help out that way. All right, so uploading a file via the AWS Java SDK. So here's what it looks like. And yes, I know this is more verbose than CFML, but it's not very hard. So the first thing you're gonna do is you're gonna grab your file, right? You know, you're gonna get your file using the file upload, like a one of your customers uploads a file on your app, and you say file upload in ColdFusion, so you know it knows how to grab that file off your computer. And then you're going to read in that file as a binary object, because that's ultimately what Java will expect. This is all stuff that ColdFusion masks for you, but does behind the scenes for you. This is using effectively the same code. It's just masking it for you. And then you're going to create a Java file object, and you are going to initialize it with that binary version of the file you just read. And then you make something called a put file request or put object request, because it's important to remember S3 is not file storage, it is object storage. It's not a file system, it's an object storage system. Small little semantic thing, but kind of important. So you'll create an object in the AWS Java SDK of com.amazonaws.s3.model.putObjectRequest, because in the AWS Java SDK, everything is either a request object or a response object. You create a request object, you tell a service to do something with that request object, and you get a response object back. So here we're creating a put file request, or rather put object request is the technical name of the object. We're passing it in the bucket we want to put in there. And I'm assuming you know the basics of S3, that there are buckets, which is like the core FTP site, if you want it, the core way, the core container for all your objects. And I assume you know a little bit about that. So we have our put file request, we give it the bucket name, we give it the file name, and we give it the Java file object. And then we tell our reference to the S3 service, which is represented there as S3. We say S3.putObject, right? Run the putObject function using this put file request. And that's how you upload a file via the AWS Java SDK. Again, I'm not arguing you should always go this route, but you need to know how to do this if you want to do the rest of the things I'm going to show you today. So John, that's the answer to your question. Why don't you use the CF file integration? Because if you do that, you can't use any of the other things that I'm going to show you here today, at least not until ColdFusion 2020 is released. So this is the route you have to go if you want to do things like storage classes or versioning or anything else that I'm going to show you today. So that's sort of the initial thing. You'll see sort of versions of this code used a lot throughout the presentation. I just wanted to sort of give you a walkthrough on this here today. Okay, so the first thing I'm going to talk about is security, because security is super important. And AWS is generally amazingly secure by default, unless you configure it not to be secure. But there's still issues around security that you should know about. And security in AWS is tied deeply into something called identity access management. And those of you who've seen me present before are probably groaning right now. You're like, oh God, not IAM again. Yes, IAM. And identity access management is important because it says what a particular user, whether it's a server or a person, can do with a particular service inside of AWS. And so IAM is important because you need to set the right permissions to say that, yes, someone can upload, this user, meaning a computer or a person, can upload a file into this bucket, or turn on object versioning, or delete a file, or whatever it is right there. And Adobe ColdFusion and Lucy, but particularly Adobe ColdFusion, all the way up through Adobe ColdFusion 2018, requires lots of permissions. I mean, a lot of permissions. It's like 23 different permissions you have to enable, and I'm not comfortable with that, because a lot of times I'm like, what, why should I have to enable bucket version tagging when that's not actually supported by the Adobe ColdFusion integration with S3? But it has to be turned on, otherwise things don't work, and that's not a good thing. It's too permissive, and I don't like having lots of permissions. And AWS's best practice always is, do the least amount of permissions possible. So if I actually use the AWS Java SDK to upload my files, my policy can look like this. In fact, my policy can be even more restrictive than this. It could just say put object. I don't have to even say get object or list the things in the bucket or delete object. I can say the policy only allows you to put things in there. And that's super restrictive. And that's the way I like to work, because it's so much more secure doing things that way. So, you really always, AWS says go by principle, least permission. That's what you should always try to do. Now, I'm not going to be able to go into what policies are like and how they work. I did do a whole talk on IAM and managing that from within ColdFusion at CF Summit 2019. The YouTube link is right here on the screen. Also, if you look for the CF Summit 2019 videos on YouTube, you'll be able to find it. It has a whole introduction to IAM and how you can manage it from within ColdFusion as well. So if you don't don't know a lot about IAM, I would recommend taking a look at that. So let's get into actual things you can do with S3 with AWS Java SDK that you can't do from the built-in CFML functions or ColdFusion functions. And the first one is time expiring URLs. Why does this matter? Why is this useful? Well, time expiring URLs means that you don't have to have buckets that are fully readable to the public, that are fully readable by anyone on the internet. And what this allows you to do is have so much more security in what you're doing. Because if you have a public read bucket, meaning a bucket that anybody can read from, then that's a real problem. Because they can steal your stuff, right? You may be like, well, it's convenient. I set it up so public read so everyone in my team can do it, can just grab files. I don't have to create IAM roles or IAM users for everybody. That means anybody on the internet can access your stuff. And there are plenty of tools. Go search. Go search for S3 bucket read tools or S3 insecure buckets tools. And you'll find a dozen different hacking tools that let you suck everything out of your bucket onto somebody's computer. Or worse yet, you've misconfigured it so badly that you allow anyone in the world to write to it, and you wake up one morning with a $2.3 million bill, which has happened not once, but many times. Maybe not $2.3 million, but $2,700, $500,000. Lots of people have suffered badly that way. So if you do, let me just say this one more time. Do not have public read buckets. Don't do it. It's a bad idea. If there's one thing you start doing differently after this presentation, let it be this. Make your buckets private so that not everyone can access it. But if nobody can access it, like let's say it's a bucket of images or movies or PDFs and you want people on your website to be able to grab that, how do you do that? Well, you create time expiring URLs. They're digitally signed through the AWS Java SDK. So it says, this link literally only is valid for 10 minutes. This link is literally only valid for up to 7 days. It can be up to 7 days that it's valid. So you know that somebody who's signed into your site or the right user is the person who's going to be able to go grab that file. And that way you don't have to have public read buckets. And how you do it, so they allow you to secure your content. They limit access to download, so not anybody can just download anything they want in your buckets. With time expiring URLs, you can actually change the name on the fly. So if you say store files as a hash in their file name for security reasons, like you don't want it to say like Brian Klaas's tax returns, you could say, you know, some hash of that and store it that way. But when I get my file back, I'd probably like to see what the name I uploaded it with, which would be Brian Klaas's tax return. And then you can do other things like specify if it's going to come in inline, so you can protect like the images or videos that you're putting in your website if it's an inline request, or attachment, meaning it'll download to the person's computer. So that's what time expiring URLs allow you to do. So John, the same thing. I mean, if you really wanted to protect your JS or CSS, you could do it the same way, do time expiring URLs that way. You definitely could. Most people are like, you're gonna see my JS or CSS anyways in your browser tools, so they don't worry about that. It tends to be more like people's individual files. And Rocky, I don't yet know if CF 2020 fixes the security permissions issue. I haven't gotten that far into my testing of it, but I do know because it's using the AWS Java SDK much more directly on the back end, basically it's a wrapper around the AWS Java SDK, you should be able to specify very restrictive very restrictive IAM permissions because it's really using more directly the pure Java SDK as opposed to sort of a custom solution that Adobe had built for the current pre-2020 version of the S3 integration. But yeah, John, you're right. Exactly. If you're time expiring your JS or CSS, it's not going to cache correctly. So you probably don't want to do that, right? You want it to be cached correctly by the browser rather than making them time expiring there. So I created a couple years ago a component that lets you sign your URLs really easily. It's not hard to do within the AWS Java SDK. This is just a nice wrapper that takes some extra parameters that you can put in there so you don't have to write that code yourself. It's available up on GitHub at github.com/BrianKlaas/CTLS3utils. It's a signing component, and you basically just say, you create an instance of that signing component, and then you say, create a signed URL for me using this bucket name and this path to this file in the bucket. And you can specify 1 minute, 7 days, inline, attachment, change the file name, all those things there. So if you're storing stuff in S3 and you want anybody to read the files out of it, any like browser to read the files out of it, please, please, please make sure you start using time expiring URLs. And you will need the Java SDK for that to happen. So the next thing I want to talk about is encrypting objects at rest, right? So you put objects in an S3 bucket, but what if a bad actor in your company is like, oh, let me go look in the tax returns bucket. Let me go look in the employee salary bucket, right? You don't want someone who maybe has an IT person who has permission stacks, those things, to see that. So you want to be able to encrypt those objects at rest. You upload them to S3, they're immediately encrypted. Now, there's a couple of different options that you have for encrypting objects at rest in S3. The one that pretty much, there's one that AWS manages the keys. There's one where you can manage the keys. And then there's via a service called Key Management Service. And then there's a bring your own key management service option as well. Unless you have very specific regulatory reasons for choosing something other than the first one where AWS manages the keys, just don't do it. Because AWS itself encrypts each object when you use this SSE S3, the server-side encryption with Amazon S3 managed keys option. AWS encrypts each object with a unique key, and then as an additional safeguard, it encrypts the key itself with a master key that it rotates regularly. So they're building all this in for you. You get all this for free. So unless, again, you have really strong regulatory reasons not to use it, use that SSE, server-side encryption S3, that default one there. So Adrian wants to know, how do time-expiring URLs affect browser cache for things like a site logo? Yeah, so you would just need to, every time the page is created, you would generate a new time-expiring URL for that, because the maximum length you can put on a time-expiring URL is 7 days. So again, as sort of John was pointing out, I wouldn't recommend time-expiring URLs for JPEGs, for JS, for CSS, unless you have things, it's really more for things like PDFs, Word docs, PowerPoints, video, audio, things that aren't sort of natively displayed in the browser itself. You can set a long expiration, but eventually it will time out. So that's why you would basically have to generate a new signed URL every time the person loaded up that page. So again, not so good for JS, CSS, images, unless you are maybe like Shutterstock or Getty, and you have a very high resolution image that you only want someone who purchased that image to be able to download in the next 1 minute or something like that. Does that make sense? Hopefully it does. All right, so back to encryption objects at rest. So here's how you do it. Again, more Java here, but this is all going to start looking very familiar to you. So you grab your file using the file read binary command, and then you're going to create an object metadata object. Yep, this is Java. Everything's an object. And in that object metadata, you're going to set the content length, because when you're doing encryption, content length is super important. Then you're going to set the server-side encryption algorithm. And in this case, it's a static variable named AES-256 server-side encryption. That's the default Amazon managed server-side encryption. And then because it's Java and you can overload methods, you're going to create a file input stream instead of a traditional Java file object for this particular version of the request. And then you're going to make that put object request just like we did when you uploaded the file there. And then you're going to pass it in the bucket name, the file name, the input stream, and that object metadata. The object metadata says, hey, encrypt this with server-side encryption. And then you say, hey, S3 service, put an object using this put file request or put object request if you prefer, and it will get uploaded, and then it's automatically encrypted while at rest, which is super handy, right? So now this is how you do server-side encryption with S3. Again, something you can't do in the built-in ColdFusion stuff. Right. So Joseph, your point, this is exactly what we do as well. We use time-signed URLs for videos in our classes at Johns Hopkins. So I work at Johns Hopkins University. We do online learning for thousands of people all over the world, even before COVID-19. And that's how we protect our videos as well, to make sure that they're only playable by the people who are enrolled in those classes while they're enrolled in those classes. But public things like site logos, CSS, JS, we do, it's all publicly available. So John wants to know, is it auto-decrypted on GET requests? And the answer is yes. Yes, it is, John. So all you have to do is basically make a plain old HTTP request. And if you're authorized to do that, S3 will automatically decrypt it for you and send it back in a decrypted version. In terms of performance, it's really, I've seen no significant difference in terms of the performance. Because it's already making, if you're using AWS Java SDK, all requests are SSL encrypted. as it is. So whatever sort of additional overhead that adds, it already has it. So it will take it and then put it sort of in a temporary holding place once the file is fully uploaded onto S3, and then encrypt it and then make it visible to any request from that point on. Yeah, Rocky, you know, so yeah, you can encrypt the entire bucket. I don't think, honestly, there's an advantage to encrypting per file than rather than encrypting per bucket. You would probably need to encrypt per file in cases where you had buckets with different kinds of files in them. For whatever reason, that's how you set up your bucket, where you'd need to have things that didn't need to be encrypted plus things that did need to be encrypted, all in the same bucket. I've seen setups like that, you know, stuff that's not greenfield or new buckets. People have been using S3 for a long time are suddenly like, well, this is where all of our customer data goes and we can't really rewrite our app, but we want to protect these files. So that's really where we would use it. The easier route to go is just encrypt the entire bucket, set up the entire bucket to be encrypted. That is absolutely the easier way to go and the way I would recommend, unless you need to do this on a case-by-case basis. All right, next up, money, saving money. Everybody likes to do this, right? So I need to talk about storage classes, because if you've only ever used the built-in CFML integration for S3, you don't know that there are multiple storage classes for storing your data, because by default, the CFML runtimes now support only the default, the standard storage in S3. But there are multiple storage classes, and I'll go over each one of these in a little bit, in a little detail as we go along here. Standard is the gold standard, right? It is replicated in 3 different availability zones. Those are separate data centers, physically different data centers in a geographic region. So US East 1 is one of the geographic regions. It's in Northern Virginia. And there are actually 5 separate physical data centers, 5 massive buildings around Northern Virginia within about a 20-mile radius of each other. And those are different availability zones. And when you upload a file into S3 standard, that file gets replicated into 3 of those availability zones automatically. So it's really good for security and for storage and all that good stuff. There's a storage class called intelligent tiering, where it'll look at the access patterns automatically on that file and say, you know what, nobody's used this in 30 days. So I'm gonna move it from S3 standard, which is the most expensive option, to infrequent access, which is a less expensive option. And then infrequent access is for files that aren't accessed very often. And then there's even one that's cheaper than that called one zone infrequent access. That means it only gets put into one availability zone in a geographic region, and it's stored at the infrequent access level. And then there's Glacier. And Glacier is really used for storing files for a very long period of time, meaning for true archival purposes. Glacier has a limited number of requests on that. And then there's Glacier Deep Archive for like, this is something we're never going to touch again, but we have to have it for regulatory reasons. That's what Deep Archive is there for. And let me talk a little bit about durability, because people usually like, well, I don't want S3 to lose any of my files, right? I'm worried about that. I have to use S3 standard all the time because I don't want anyone to lose my files. Well, let's talk about that. The durability mechanisms in AWS and S3 in particular are kind of mind-boggling when you come right down to it. S3 guarantees 11 nines of durability in distributed storage, not just like 11 nines on one hard drive, but 11 nines of durability in distributed storage in at least 3 availability zones, sometimes as many as 5 availability zones in a single region. That is incredibly hard to achieve. You are 400 times more likely to get hit by a meteor than to lose one of 1 million objects in S3. That's how good 11 nines are. And then they have these formal proof of correctness algorithms that they built that map across all the different systems that S3 has integrates with. They do checksums across these loosely coupled systems, including checking for bit slips in RAM. So while something's going over the network, to make sure that none of the bits are wrong. They have complex actuarial models that predict when a hard drive that's actually used are going to fail, so they can take those hard drives out automatically. And they have these durability monitors that, or auditors, excuse me, that repeatedly crawl every single byte of data in S3 that verify that when you retrieve your stuff, it will be perfect and it will be correct. It's really pretty amazing that they provide all of this, which you could never do in your own local data center. Believe you me, you could never do this as part of the S3 costs, which are already pretty darn cheap. There's a really great video that I put on the screen here, the link for it on YouTube. It's from 2 years ago at reInvent, their big annual conference. The product manager of S3 gave this talk about how they protect your files. It's fascinating. It's stuff I couldn't dream of doing myself because I'm not nearly smart enough. But I don't worry about stuff getting lost ever in S3 because it's just not going to happen. So how do you specify a different storage class? Because again, like I said, what's built into CFML, it automatically just shows, it puts it into S3 standard. And S3 standard is the most expensive version, most expensive storage level. So here again, we're going to read our file in, we're going to create a Java file object, we're going to create a put file request, right? Our put file request there using the data that we have. And then we create a storage class object. And into our put file request, we set the storage class using whatever value of the storage class we want, standard, one zone IA, Glacier, whatever it is. And then we tell S3 to put that object. And with that storage class object as part of that request, it puts it into the correct storage class. And these prices, they can be different. There's just definite significant differences in the cost among different storage classes. So this is the sort of most recent pricing. If you're watching this a year from now, these may change. So standard storage for the first 50 terabytes a month, you're paying basically 2.3 cents per gigabyte of data stored. That's standards. That's the gold standard replicated across 3 availability zones. Intelligent tiering is basically the same price. But if you're using intelligent tiering, which says move it from standard to infrequent access when it's not been used in a while, there is an overhead of that. And that's 1.25 cents per gigabyte of data analyzed, and also a quarter of a penny for every 1,000 objects that you analyze. So there's an additional cost to intelligent tiering. I'll talk a little bit more about this in a second. S3 standard infrequent access is only 1.25 cents per gigabytes. Now, why not just go with that? Well, there is a difference in latency between standard storage and infrequent access. The difference to 99.9% of your customers and use cases will be negligible. We're talking in standard storage, response times are generally under 10 milliseconds per get file request or get object request. In standard infrequent access, that may vary as much as up to 1 second. So you will have that and if it's standard storage, you're under 10 milliseconds. Infrequent access means it could be anywhere from 10 milliseconds to 1 second at half the price. And for a lot of your content, that really may not make much of a difference, right? That really may not make much of a difference. You have to know your use cases, but it's a lot cheaper if you're willing to suffer that up to 1 second latency on getting the request. But I use infrequent access a lot, and I rarely get 1 second latencies in the pulling of the files. One zone infrequent access means it's stored at the infrequent access level, and it's also only put into 1 availability zone, not replicated across 3. That is 1 penny per gigabyte per month. Glacier is 0.4 cents per gigabyte per month. Glacier has a limitation on it that if you put a file in Glacier, it may take anywhere from 1 to 12 hours for the file to be retrieved. So it's actually more like, imagine getting a file off an old tape, like a magnetic tape. That's actually almost literally what Glacier is. So it can take anywhere from 1 to 12 hours for that request to be fulfilled. It's not real time. And Glacier Deep Archive, you are limited to 2 requests for that file per year. So you cannot make more than 2 requests for that file per year, and it's even cheaper. But most people that have. And yes, Mark, you're right. You do have to schedule retrieval from Glacier. It's not like you just make an HTTP request and say, give me this file. You have to put create a Java object, create a Glacier retrieval request. It goes to AWS. It gets put in a queue. You get an ID back on that Glacier request, and then you'll have to poll S3 to say, hey, is this request done? Once it is, you'll then be able to get your file. So yeah, it's a completely asynchronous activity when you're working with Glacier. Good point. Thank you, Mark. So storage classes are good. They can save you a lot of money. But the thing people tend to forget about is egress, data out, egress. And this is important. So NASA, in the last few years, for example, has been really working hard to put all the data sets in kind of an open format. So anyone, scientists around the world, can collaborate with them. Hobbyists can look at the data, analyze it, use it for machine learning, whatever it is. They're trying to be more open about a lot of the data they have. And they chose S3 as their primary storage mechanism. And they are going to, by I believe it's 2025, they have estimated, or they plan by 2025, and it's been budgeted this way, that they will have 32 petabytes of data in S3 in public open formats. So in this planning, they kind of forgot that when you pull data out of AWS or Google Cloud or Azure, no matter which one, when you pull data out, it costs money. There are data transfer out fees in AWS. There's interzone data transfer fees in AWS as well. Data inside of egress and data in and out is a whole complicated subject. But what they found based on current usage patterns, they have 32 petabytes right now in S3. By 2025, they estimate that they're going to have 247 petabytes of data, and that based on current usage patterns, they will be paying $30 million a year in data egress charges alone by 2025. $30 million a year just for people to pull the data out of S3, because you do get charged. Now, unless you have, again, 247 petabytes of data you're pulling out, you're not going to have those kind of bills. But you have to consider that as one of your costs. And you might want to consider doing CloudFront, which is AWS's content distribution network, in front of your S3 buckets, so that requests, we get a big benefit there, right? Which is that you go through their global client content distribution network with, I think they're up to 57 or 70 some, I can't remember what the number is. I think it's around 70. 70 points of presence around the world, so people don't have to go all the way to, say, Virginia to get the file, though, if they're in Hong Kong, there's a point of presence in Hong Kong, and the stuff gets cached in the CloudFront edge locations. It makes things better. We use it at Hopkins, at Public Health, where I work, because we have students all over the world, and we want these large video files to get to them as quickly as possible. In February this year, for example, we did 4.6 terabytes of video data, and we use CloudFront. So we have the 4.6 terabytes of data, plus CloudFront distributing that at all the points of presence to our students all over the world. We paid $406 for CloudFront, the data out charges, via CloudFront. So we get all that extra benefit. If we had done that same amount with S3 alone, we would have paid $414. Now, it's not a big difference, right? But we don't get the global content distribution network. And as your costs increase in data out, using CloudFront often makes a lot more sense, because it will help to keep those costs lower, and the data will transmit much faster to your customers, because it's over Amazon's private backbone, not over the public internet. Right, and yes, petabytes of data and their egress and ingress fees, Charlie, is absolutely part of what make Jeff Bezos the richest man in the world. But yes, you do, John, as John points out, you do have to be aware about how you sign those URLs when using CloudFront. You want to make sure that they're sort of like not changing very often, because otherwise you may not get the proper caching that these edge locations provide for you. So that's a good point, John. But just again, you look at your data patterns, look at your usage. For some people, just linking straight to S3 is great. They won't need it via CloudFront. But when you're starting to talk about terabytes, around 5 terabytes of data, you do start seeing a divergence in the cost there. So pay attention to that. All right, so the next thing I want to talk about is lifecycle flows. And really what this is automatic archiving, moving files from one location, from one storage class to another when they're not being used, so that it saves you money. Again, we're still talking about money here. And yeah, like I said, this is about don't pay for files you don't need. Not only don't move them from one storage class to another, but get rid of files you don't need anymore. So there's two kind of lifecycle flows in S3. One is called transition actions. And this is something like after 90 days, move all the files that have been there for 90 days from standard access to infrequent access, right? So you save half your cost, because are people going to be looking at those files after 90 days? If they are, for example, for us at Hopkins, homework files, right? That's due on a certain day. The vast majority of students upload them in the 15 minutes before the assignment's due. The faculty grades them. After 90 days, is anyone going to be looking at those files again? Probably not. Why should we be paying S3 standard storage prices when they can be moved automatically without me having to write any scheduled tasks or code to do that into infrequent access, or even Glacier or something like that? And then there's expiration actions. And these are actions that basically say, get rid of the files. After 180 days, no matter what, delete the file. So you might want to do something like on logs, on raw server logs, or generated files or generated reports that are now out of date after X number of days. And the point of these lifecycle flows is that AWS handles this for you. You don't write code to do this every day or every hour and check all this stuff. This is all managed by inside of S3, and you just have to set it up one time. So let me show you how to do this in code. You can go into the AWS console and do this, and I know a lot of people do because they're like, why write it in code when, you know, I can just do it in the console? Sure, you can do that too, but it's important to know about it and how you would do it from CFML, especially if you're managing lots of buckets or well, lots of buckets inside of your CFML app. So you're going to create something called a bucket lifecycle configuration object. And that bucket lifecycle configuration is going to take a series of rules. If you look at the second line of code here, you may notice something a little bit different. And there, you notice there's a $sign in the middle of the object name. You have bucket lifecycle configuration $sign rule. Well, thanks to Ben Nadel about this. I didn't know about this. This is how you reference inner classes in Java inside of ColdFusion. So if you have a jar or any Java class that you're using where there's like an inner class that's not, doesn't have a it's an inner class there, you would have to reference it via that $sign rule thing. And that's how it's done in the AWS Java SDK. So that's how we have to do it here. And then I just give the rule an ID, right? Some sort of ID that I can read there. And then I'm going to create a storage class object because I'm saying this is where I want it to go, the storage class I want it to go in there. And I create a transition object. Again, that inner class thing, we have that $sign for transition. And then I say, create that transition object with the number of days being 30. So after 30 days, use this other storage class, one zone infrequent access. So basically that transition line of code there says, after 30 days, move all objects in this bucket to one zone infrequent access. So that's basically, you write one line of code and you get all this power behind it. Then you set the transition and the rule. Now in this case, I'm also, there's a demonstration here of how you do those file expirations. So I've also added a rule where I say set expiration in days. So this means that after 90 days, all the files in this bucket will be deleted, right? So I'm doing both here. So in one run, one execution, one call to S3 on set bucket lifecycle configuration, I can say not only do I want to set this transition from one storage class to another, but I also want to delete files after this number of days. You don't have to do both. You can do one or the other, but you can do both if you want to. You have to enable that lifecycle config. You know, that's the last thing you kind of have to do is enable that lifecycle config. You set the rules in the lifecycle config, and then you tell S3 to actually use that configuration. So again, this is how you would do it in Java, or you can do it in the console if you want. But you know, they're really powerful. Lifecycle flows can save you a lot of money because it just gets expensive. You know, the more you put into AWS, the more you put into Azure, the more you put into GCP, the more expensive things gets over time. And everyone wants to store things endlessly and forever, but it's very unlikely you need all your files forever, or that you certainly need them inside of S3 standard storage forever. So I really recommend setting up a lifecycle rule to move files to one zone and frequent access after 30 days. This is a good amount of time. Most files often aren't used for more than 30 days. And if you know that they are, then you'd put them in maybe a different bucket. But the vast majority of user-generated files aren't used after 30 days. And so you can set up a lifecycle rule to do that. Now, the reason why it needs to be 30 days and not like say 5 or 7 is because lifecycle flows only work when you move from standard to a different storage class. The files have to spend 30 days in standard storage. It's an AWS internal rule. So that way they make it so like, you know, if you're Instagram, everything's in standard access, and then after 7 days, move it down. No, they don't do that. It's got to be 30 days. It's a way they sort of make sure that they're getting their money out of you after like a whole good month there. Now, if you want to set up a lifecycle rule that said, move things from a cheaper storage class to a more expensive one, there's no time limit on that. You can do that as soon as you want. But if you want to go down the chain, they have to be at least for 30 days in standard storage for the lifecycle rule. You can store those files originally in infrequent access. That's fine. But if you want to use a lifecycle rule where something is in standard storage, it has to be in there for 30 days. Now, there is also a 128 kilobyte minimum file size for infrequent access storage classes. If you have files that are less than 128 kilobytes, it's not going to move them. You may as well just keep them in standard storage because 128K is the minimum file size that you are allowed to put files, to transition files into infrequent access or one zone infrequent access there. It's also important to note that if you try to do a lot of different lifecycle flows, you can only have one filter that affects all files in a bucket. You can say this filter only applies to the files in this directory path, this path, this object path, like the users folder inside this bucket. You can say this lifecycle rule only applies to that folder, and this other lifecycle rule only applies to this other folder over here. But for the whole bucket, you can only have one lifecycle rule applied to the whole bucket that's here. Just something to keep in mind if you're planning on using this and want to have more granularity in how the lifecycle flows work. Now, you can filter the objects that have lifecycles applied to them based on the key path, the path to that file, the object key. So if it's in a series of folders, you could say just the stuff in this one little folder down here gets that. And you can also use tags, which I'll talk about in a little bit, to filter and say this lifecycle only applies to these files with these tags added to it. But they're a great way of saving money to do that work automatically, so you don't have to write ColdFusion code or any other kind of code or bash shell scripts to make that happen for you there. All right, next up, powerful tools. Some other powerful tools that are available in S3. Versioning. S3 can do versioning for you automatically. It does it on a whole bucket label. The whole bucket is versioned. But if you don't want to keep track of multiple versions of a file, you don't have to do that. S3 will do it for you automatically. So when you put a file into S3, S3 returns the version ID value in a response header called XAMZ version ID. And then you would need to store that to put in your own applications for reference later. So you could say, here's the 7 versions of this one file. Now, S3 won't tell you what's the differences between the file. It's not Git. It's not a diff engine. It just will store automatically the versions of the files for you, so you don't have to do that work. You would need to store the list of versions somewhere so you know what the differences were. Your application would know the differences were. But the actual labor of versioning files and making sure they're not overwriting each other is managed automatically by S3. And again, here, we're just going to create a bucket version config. And we're going to, in that bucket version configuration request, we're going to say, the bucket versioning config, we just basically create it, set the status to enabled, and then in our bucket version, a bucket config request, we are going to turn that on, just add it to it and say, yes, turn it on, and then tell S3 to set the versioning of this bucket to on. That's how it works. It's pretty straightforward in that regard. John asks, there's no way to ask AWS for the diff info? No, there isn't. AWS doesn't look at it at all. It doesn't worry about what kind of file it is. It won't look at the diff. It will just say, all I know is a new version was provided to me. And it will manage that for you in the background seamlessly. So you don't have to worry about how many versions or anything like that. You need to know, though, what the difference is in the content. That's not something that they'll do for you. And there's no way to say, like, diff these 2 files. You could grab 2 versions of a file out of S3 and run a diff engine on them, but S3 won't do that for you. So versioning is easy to do because you don't have to worry about files getting overwritten and stuff like that. But you're going to pay for every version. Every version is a different file, a different object in S3 then. And even if you were to turn off versioning on a bucket, older versions of that file are suspended there. So there is a lifecycle rule you can apply to have old versions auto expire. That's the set non-current version expiration in days method. And you can pass it a value. You can say, so like after 30 days, anything that's not a current version of that file, just go ahead and expire it automatically for you. So, versioning can be useful. It can be powerful if you want to let AWS take care of that sort of the file management of it, but you still have to keep track of the versions. Or AWS, well, you can list the versions of a file, and it'll give you all these like random IDs. It just won't tell you what is actually different between the different versions. So like in Git, you do a commit message. You'd want to do something similar in your application that used versioning in S3. All right, next up is tags. And the great thing about tags is they allow you to find things in a human-readable way inside of your AWS resources. And tags can be applied to everything. Everything in AWS, well, almost everything in AWS, almost everything. They can be applied to servers. They can be applied to load balancers. They can be applied to files in S3. They can be applied to Lambda functions. They can be applied to, video encoding workflows. Lots and lots of different things can have tags applied to them. And tags are simply key value pairs that make sense to you. That's all they are. They're just key value metadata that you would attach, that you would add to your files, your EC2 instances, your load balancers, whatever it is. And there's lots of different ways in which you can do tagging. You can say like, okay, this EC2 instance has a tag of department and the value is security. So I know the security team owns this EC2 instance. Because as you build in AWS or Azure or Google Cloud or any cloud environment, there's going to be sprawl. More people are going to be using things. It's going to be hard to know who's responsible for what, right? So what's great about tags, particularly in the context of S3, is that you could say, okay, somebody put this file up here. S3 isn't going to know who that somebody is. I mean, technically, you could look through the logs and try and parse that out. But that's way too much work. What you want to do instead is say, add a tag of owner, where the key is owner, and the value is the user ID or the name of the person who uploaded the file up there. And then inside of AWS, you can search on those tags. You can search for all the files owned by Bill Bridges. You can search for all the EC2 instances that belong to the order fulfillment application. You can search for all the files that are, restricted in their confidentiality or HIPAA compliant, as long as you add the tags in. This is very important. AWS doesn't create these tags. You have to add them in, but it's really pretty easy to do. And yeah, Adrian, versioning is a good thing. Tags, are great because then you can do a version tag rather than AWS's versioning if you want, and you manage that versioning number if that's something you want to do. Tags are really important. They're really powerful. If you haven't started using tags, start using. This is another thing. If you only do one thing today, aside from the signing of the URLs, definitely do the tags. Start figuring a strategy out for that. So here's how easy it is to create a tag and add it to your request. So again, first couple lines we've seen before. We're creating a put file request right there. And then we create a tag object. And all we do is pass it a key and a value, and boom, we have a tag. Then we create a file tagging object into which we put our tag. And then in our put file request, we set the tagging. We can have up to 10 tags per file in S3. So it isn't just one thing you can add. You can add like 7 or 8 different tags. You can search on each of those, which is really great when you're trying to do reporting and cost allocation later on. Now, there is a special kind of tag you can set up called a cost allocation tag. And if you're using cost allocation tags, they're applied on a per bucket basis. So the cost allocation tag says, I'll filter this entire bucket by these cost allocation tags. But what they do is they allow you in your monthly bill to see what amount of money was allocated to the different values in that tag. So for example, in a bucket, you say the key is department. You can set up that department key as a cost allocation tag, and then all the individual instances, whatever it is, like accounting, receiving, shipping, security, whatever, it'll break your S3 bill. In fact, all of your AWS bills will get broken out along by that tag, which is really great when you're trying to figure out who's supposed to pay for what in your AWS resources there. You have to activate it in the billing management console, and it can only be activated for the master account. So that can be a definite problem. If you don't own that master account, let's say you're working at a corporation where there's someone high up in IT or high up in accounting or APAR, who does the bills. They're the ones who have to, whoever the master account is for your entire AWS organization or your AWS deployment, that can only be activated there. But they're great, again, for breaking down those bills right there. Yes, so Adrian asks, basically I have a thing and that thing has files associated to it. You can tag the file with that ID and search the files by thing ID. Yes, you can search by tags. Basically there's other Java SDK functions that I'm not going to show you here that let you search by tags. You can do it on the CLI as well. And then the cost allocation tags basically let you break stuff out in your bills. But the vast majority of times people use tags is not necessarily for cost allocation. It's to find things, right? Like say, give me all the servers that the marketing department are running, right? Because it's hard to know because people have named things in crazy ways. And if you have 15 people with AWS accounts at your company or 500 people with AWS accounts at your company, keeping track of that can be really, really hard. But that's exactly what tags are intended for, Adrian, is to be able to tag something with that thing ID and then search for and find it with that thing ID later on. Super powerful. So probably the best guide if you're looking at doing tagging, and again, I really recommend you do this, AWS sees what their customers do. They're very upfront about this. They look at customer usage patterns, we look at it, and here's what we found to be the best practices in tagging. So this URL right here, it's the AWS tagging strategies created by AWS themselves. Highly, highly recommend it. There's a really good, if you're looking at tagging through the security lens, K9security.io has a really good guide to tagging in AWS as well from a security sort of lens on things with some really good ideas for your security team and looking at considerations you might have in a more regulated environment around the kinds of tags that you should be using. So tags are awesome. Highly recommend them. All right, so I've got 5 minutes left, and I just want to mention a few other things that AWS S3 can do that I didn't get a chance to talk about today. I mean, I've really only covered like 6 things. It's been like 50 minutes. So there's a lot more than it can do. S3 can do website hosting. This is great for static sites. My blog, brianklaas.net, is hosted in S3. And I paid nothing. I think I paid $1.11 last month for my website, for CloudFront in front of it, for everything being done over SSL. It's great. And at Jamstack sites, it's a great way to put your HTML, CSS, JS on S3 and then talk to like a serverless backend or an EC2 backend somewhere else. So it can do website hosting with literally a click of a button. S3 can be used as a database. This data you store in S3 can be used as a database. So you can store data in S3 in JSON, in Parquet formats, lots of different sort of standardized formats. And then you can use tools like Amazon Athena and S3 Select to run queries on the JSON files or the text files or the log files or whatever, basically text files in any kind of format that you store in S3. And you can query that just like you would a database. Now, is it as fast as a relational database? No. Can you do stored procedures? Not really. But if you want to be able to query terabytes of data that are just log data or historical data that are stored in text-based formats inside of S3, you can do that with both Amazon Athena and S3 Select. Athena is the more sort of robust, powerful tool. S3 Select is useful in a much more limited sort of number of situations, but you can read about both of those on the AWS website. S3 fires off events every time you put a file in there. And what's great about that is that you can then attach Lambda function listeners, so that every time a file is put in a bucket, you can run some sort of code on it. And you could say, run some security code. For example, we have listeners that say, how big is this file? If someone uploads a file in one of our student directories that's more than 10 gigabytes, they are likely doing something very, very wrong. And so we get notified and people can investigate. We do Lambda listeners on buckets for where videos get uploaded and it fires off of an event. And we automatically do this complex transcoding process where the video gets transcoded into multiple different versions and formats for better streaming to students around the world. That's all handled manually. There's also a function called S3 batch where you can run functions on existing files because the events only happen when a new file gets uploaded or deleted. S3 batch lets you run things on existing files. So if you have 1 million existing files and you want to add tags to all of them, because there's one tag that gets applied to all of them, you can do that with S3 batch. There's more security. You can lock individual objects so that an individual object in a bucket cannot be deleted by anybody. Unless it's the master account for your entire AWS organization. And even then there's ways of saying, this file can never be deleted, even by the master account in this organization. Again, really good for regulations, regulatory environments. You can require that multi-factor authentication devices are used on delete. So if you try to delete a file, you have to respond to a text message or use YubiKey or something like that to make that happen. You can automatically replicate your files across regions. So if you're worried about disaster and disaster recovery, like a nuclear bomb hits Northern Virginia and wipes out everything in US East 1, well, you can automatically set things up to replicate to another region, let's say in Tokyo, or Sao Paulo or something like that. Automatically behind the scenes, you don't do anything except click a button and pay the bills. That's it. You can even do data sync for your on-premise data. So if you have terabytes of data on-premise that you want to move into S3, there's a tool called data sync, which will look at your NAT devices, your NAT storage, in your local data center, and it will start copying all of that up into S3 in the background using all their compression algorithms, and it'll save you money there. And then you can keep it live, a little live sync. And then at some point you can just flip the switch in your application and you're pulling stuff off of S3 instead of your local data store there. It's very, very powerful and useful. We've used it, really happy. You can even set it up so that the requester, the person making the request, pays for the data egress. So if you're a company that shares large data sets with partner companies, you can say, y'all get to pay for pulling down this 5 terabyte data set every time you use it. You can do that as well. So you're not paying for the data out, but the person who is making the request is paying for the data out. So those are just some of the things that S3 can do. I know I didn't get into lots of details on many of them, but I hope this gives you inspiration to think about the different ways in which S3 can work for you from within your CFML applications. At the very least, start signing those URLs, start putting tags on your objects, and think about different storage layers. You can have your S3 bill by just using lifecycle rules and different storage layers, using the code that I've shown you today. I love this kind of stuff. It makes my life easier as a manager, as a developer, and for a manager as a team of developers. It's so easy to use, and it's rock solid reliable. I love using it. And yes, at the end of the day, I wind up giving more money to AWS, but they make my life easier, and we're able to do really cool things that we as a team of 6 could never do on our own. So try it out, go out and do it yourself. Again, here's all of my contact information. The link to my AWS Playbox app, which has all the code that I showed you today, is there. On my blog, brianclaas.net, I've been writing up a lot about S3. A lot of the details I covered here today and then some are covered in various blog posts about using S3 from within CFML. You can also hit me up on the Twitter. I'm happy to answer questions. I can't always solve everyone's problems, but I'm happy to answer the questions that, that you do have for me. I will do my best to answer them for you. Yeah, so Adrian pointed out that he used S3 to store IIS logs and queried with Athena. That's a great use case, Adrian. We do the same thing. We store our logs in there, and when we need to be like querying the raw IIS logs, we use Athena to do it. It's relatively fast. You know, it's great for ad hoc querying for that kind of stuff, forensic analysis that we need to do. Really good use case there. So thank you, everybody. Again, I'll stick around, answer lingering questions that you might have. Charlie, I know, has a few more things that he wants to say. So I'm going to bring up this participant list and make Charlie the host again so that he's able to talk about the things that he wants to talk about. But like I said, I'm always happy to answer questions, and thank you all for being here. And Charlie, you're the host again now.
Yeah, it's really interesting. I wasn't able to unmute myself the whole time. So
really?
Good thing there wasn't a problem that I needed to speak up and get your attention. But that's another, odd thing that
Zoom, yes, with Zoom, right,
has only this choice of one of us being the host. At least with Connect, I could be the host and make you a presenter, and I still had full control. Which, as kind of a host, it's tough because if you were having trouble and you couldn't hear us or we couldn't hear you, that would be tough. So that's interesting. But you mentioned that, and this is making the sausage stuff again, Brian. You mentioned that your Zoom, you have the webinar add-on, don't you?
Yeah.
So that probably changes things. That you probably
because you could make me a presenter in there.
You
and you can also, if you set somebody as a host inside the Zoom web admin interface ahead of time, they're automatically, if they sign in with that email address.
Oh, co-host, right.
They're co-host, right.
So that's what I should have done. So there's a lesson learned. Thank you for that. So there's a question for you.
Yep. Yeah, so John, it said, my examples, it looks like I'm uploading files to a server drive, then transferring over to S3. Is there a way to upload directly to S3 and then use the SDK to do stuff? Absolutely, yes. So that's the way most people know how to do it, John, is I upload to my ColdFusion server. I want to keep that as simple as possible. But there's something called it's a pre-signed URL. Just like you would generate a signed URL for grabbing a file out of a private bucket that's not world readable, there's a function in the AWS Java SDK that will also be available inside in ColdFusion 2020 natively called generate pre-signed URL. And what that does is in your HTML form, your action value is that pre-signed URL that points to your bucket on S3. And it already has the right permissions encoded into the very long string right there. And so when you submit the form, it's going to have to be a two-part process. One, the file gets uploaded to S3 using that pre-signed URL. And then AWS, in response to that, will return, some values to you. This is done in JavaScript. You'll have to grab those values like the file ID or something like that if you need them. And then the second half would be like, then tell your ColdFusion application server that this file was uploaded and then do something with that data there. But that's exactly how you do it. It's generate pre-signed URL is how you would do that to upload directly to S3, avoiding your ColdFusion servers, which often is a really good idea. If you have customers uploading 1 gigabyte, 5 gigabyte files, you really better make sure you have that much RAM available on your ColdFusion server to make sure it doesn't crash it with someone uploading a 5 gigabyte file or a 10 gigabyte file, because it'll suck up all the memory on your ColdFusion server during that upload process. So yeah, that's a really good point. I was trying to keep it simple, but it's generally considered best practice to use the pre-signed URL to upload to S3, let them take care of all the data and bandwidth, and then you sort of get the result back and then do something with it within your ColdFusion application. So Dean wants to know, if you have files you've already uploaded via the CF file, can you modify them with the AWS Java API? Absolutely, Dean, you can. Yeah, so any file, I just showed you things like, versioning, encryption, that kind of stuff. You can do anything in the AWS Java SDK. You can manipulate files, you can delete them, you can copy them, you can change the metadata on them, you can add tags, you can do whatever you want with them once they're inside of S3 using the AWS Java SDK if you use CF file to get them there in the first place. Absolutely. Oh, in my video, Charlie, I have a screenshot. It's from the Studio Ghibli film Spirited Away as my virtual background. Mark was just commenting on the background there. Oh, it's not. I don't know if it's a monastery. It's if you've seen the movie, it's from the town that the girl sort of and her parents get trapped in, and this is the town at night. You can see like there's a fish head right there. There's a little fish head statue. This is just like a scene in from the town there. It kind of looks. It's very, as it's very Japanese looking. It kind of looks like a little bit like a monastery, I guess. Oh, Royden, great question. Royden wants to know, Rajan, excuse me, wants to know why version 1? What's the problem with version 2? So version 1 comes as a single jar file. Version 2 of the SDK comes as essentially a Maven project that you have to build. And that doesn't work very well when you're trying, because what's good about it, right, is instead of getting the 400 megabyte jar file, you can say, I only want S3, I only want Lambda, I only want IAM as the components that I'm going to use in my deployment. So it helps to keep memory consumption down, helps to keep your jar deployment smaller. That's great, but in ColdFusion, that's not how we work. Basically, you just dump a jar file in there. You can pre-compile those jars if you want to and add them to your CFusion lib, but then you're limited only to those specific services. AWS is committed to maintaining and adding to the version 1 SDK for the foreseeable future. AWS's internal services largely run on Java 8. And version 2 of the SDK requires at a minimum Java 11 because they use a lot more sort of the modern features and async IO and things like that. So there are some performance benefits to the version 2 of the SDK, but you have to build it into your deployment bundle using a tool like Maven or Gradle or something like that. And then you again also would only have those access to those services. The nice thing about the 1.x version is it's a big jar. Yes, it takes up more memory, but then you have access to all the services. And AWS, like I said, has committed to updating it and keeping it up to date because they need it. They need it for their own internal work because they use it very heavily themselves. So even when they add new services, announce them at re:Invent, they automatically are added to both the 1 and 2.x versions of the SDK. Yeah, so John says, following up on my earlier question about uploading to S3 and then using the SDK, we're using the CFML function file upload in Lucy and specifying a file system path, which is S3://. So are you suggesting the file path is a signed URL? No, I'm not actually. So in this case, you would have so in your HTML form, you would say the action value is that pre-signed URL. And then you, in your code in your form, would need to know, I mean, basically when you generate a pre-signed URL, you have to say, this is going to be the name of the file in this path in the bucket. So you would know that already in your code. And then so you'd be able to just basically tell your ColdFusion server, okay, we got a success message back from the upload from our browser. Now we know that we told in generating this pre-signed URL that it was going to be at this location. Go grab it there and do whatever we want with it there. Does that make sense, John? Okay. I don't know that drop zone necessarily works with, so I know some do, some of the HTML5 uploaders do work with S3 and pre-signed URLs. I haven't tried that. I don't know. I guess I'd have to find out. You might want to follow up with me on that, John, because I have team members who are much smarter than me and doing the drag and drop uploaders and stuff, and they might know if drop zone works or what other ones they have worked pretty well with the pre-signed URL for uploading the file. Yeah, I know some things, but that's why I hire people that are smarter than me so that they can do the hard work and I can just sort of do the big picture and fun stuff on AWS, like Lambda functions. That's my jam right now. Other questions? Happy to answer them, or Charlie, I'm gonna turn it back over to you. Wrap it up.
Yeah, no, just happy to wait and let's see if there's other questions.
Sure, my pleasure. I can wait.
Speaking of Lambda, you might want to mention Pete's efforts with?
Oh yeah, so
enabling?
yeah, definitely. Thank you, Charlie. If you're interested in writing the Lambda serverless functions inside of CFML, Pete Freitag has done an amazing job with a tool called Fuseless. So if you go to fuseless.org, you can actually write your Lambda functions in CFML using a sort of stripped down version of the Lucy runtime, which is really cool because then you can write your Lambda functions instead of Node or in pure Java or Python. You can write them inside of CFML using Fuseless. It's a pretty cool project. Definitely useful. He uses a lot for his, not FuseGuard, it's the service. What's the name of it, Charlie? Why can't I remember? The
Sorry, I
checking.
looked away for a moment. Somebody
the security
was sending me a
check
private
service
chat.
that Pete has.
Well, Hack My CF, you mean?
Well, I think he uses it for Hack My CF, but what's the other one that you can do on? It checks your code, the code checking.
Oh, Fixinator.
Fixinator. Thank you. God, I couldn't remember. Yeah, he uses. It's all written in Lambda in ColdFusion using the Fuseless project, which is pretty darn cool. Because Fixinator is really, really cool. And if you haven't looked at Fixinator for checking and doing security audits on your CFML code, I highly recommend it. Pete's a very smart person, great product.
Indeed.
All right, I haven't seen any other questions come in the last couple minutes, so I guess we're good to wrap up.
All right, sir. Well, again, thank you very much. And I didn't have any closing comments. Usually I would have switched to a set of polls, and I may get that going in Zoom, but we know you rocked, so we don't need to see the polls. And I'm sure the audio was great because nobody complained the whole time.
Oh, good.
So that's excellent. And hey, just as a thought, you mentioned the concept of using logs and doing analysis with that. And if you there's people that would be interested in that topic. If you or anybody else who mentioned it would be interested, that'd be a topic that people would be interested here. There's, of course, lots of solutions for handling logs, but one that's related to AWS and its solutions would be compelling to some people. So I'll say that'd be a cool topic.
Yeah, I don't know. I think it was Adrian who was mentioning that earlier. Yeah, Adrian, who was on here earlier. I don't know if he still is. I think that would be a great presentation. Really cool because you're using S3, using Athena. How do you do log analysis in a kind of ad hoc way? I think that's a great idea.
Excellent. All right. Well, if there's no other ones, looks like mostly just people again saying thank you, and I'll say thank you. I'll go ahead and stop
Thank
recording.
you.
Yeah, you bet.
Thank
and
you
look forward to having you again, and see everybody on another one. I'll get an announcement out hopefully later today for the upcoming sessions.
Great.
All
Thanks,
right.
Charlie.
Until again, talk to y'all later. Bye.
Bye-bye.